Hello, Video Land. We're starting a new mod, Day 1, Electrostatics, which is the study of electric charge at rest. We've got the word static previously. So, we don't really know exactly what electric charge is, but we know a lot about it. So what we know, the very basics of what we know, is usually an atom, say the atom has 3 protons. So I put 3 plus signs in there, and it would have then 3 electrons. And the electrons have a negative charge, the protons have a positive charge. So I have 3 plus signs and 3 negative signs. So in the very basic model is no net charge. So we would not call this a charged particle. We would not call it a charge. So what happens to change that situation? So once in a while, it will gain an electron. So if I add an electron out here, we now have 4 negatives, 3 positives. So now we have a net charge, and it is a negative one. So it changed from no net charge to a negative net charge. And if, for another scenario would have been, if instead of gaining an electron, it lost its original, the one that I added will lose that, and the other one. So we lose that outer ring altogether. So with that gone, we have 3 protons, 2 electrons. So now we have a positive charge. Any charged particle, positive or negative, is referred to as a charged particle. So when I say it's charged, you're not sure if it's negative or positive. Negative charge has extra electrons. Positive charge has missing electrons. All right, so let's look at a demo. We'll take a balloon and we will see what we can see about charges. So, we need a little kind of a string or something. Lots of string and a balloon. So, who has hair they're willing to mess up?
Oh no, I hate this game.
I hate this
You don't
game.
mind?
Why is this so
Okay.
sad?
My hair's in a braid,
Start
so it won't be
rubbing
very.
while I set up the string.
Yay!
Yes. I feel like we've done this before with Zach doing this. I don't know why. I just feel like this
His hair has good bushiness for it.
is good bushiness.
Are you
All
gonna
right.
shock one of us?
Zach?
Volunteer.
Rubs. Can you show Video Land what's happening?
Hello.
As Zach rubs his hair, electrons he's rubbing them off of his hair. And he's putting them into the balloon. Thank you. Alright, that's good. This may not work well because it's a humid day.
Oh, yeah.
We're gonna see if it does. Alright.
Okay, see if you can leave the balloon there, and it'll just sit.
Alright, how many balloons do we need? 2 balloons. Alright, would you read to me the what we're gonna demo? We don't all have to do it. We'll just read step 1. I think it's working.
Blow up the balloon and tie them off so they each stay inflated.
Okay.
Well, we did that. We didn't even have to do that step.
Alright.
Tie some thread to one of the balloons and attach the other end of the thread to the ceiling with some tape so that the balloon hangs from the thread.
Alright.
Here we go. Make the length of the thread so that the balloon hangs at about the same height as your chest.
Okay. Alright. Who wants to get up on a chair? Zach, can you?
I can try now.
Sure. There you go. Thank you.
I mean, no one's good dumb.
No, I know.
Just tie it either to the string that's already there.
Oh, look at
or
this
to
in
the
action.
ceiling.
Yeah.
It's like an action film. Alex,
Yes.
you're missing this action film. I know you'd have good commentary on
So
this.
we want it to hang about this high. So, and I can cut the string. That'll help you.
Yeah, you keep on charging that balloon.
I think it's so very charged.
Do you want me to read the next step?
Sure. Here, we can cut some of it.
Tape the.
This one.
I said no camera.
Everybody tying it? Cool, awesome, thank you.
Take the balloon that is hanging by the thread and rub it. Oh, it has to be the one that's hanging by the thread.
No. Well, we can just untie that.
Got it. No. I got it.
I just stand over here and do that. So this is supposed to be uncharged?
It's hanging by the thread and rub it your hair a little. It says a little.
Okay.
This will cause the balloon to pick up some electric charge. Now back away from the balloon and allow it to hang there. Take the other balloon and rub it in your hair just a little. Okay, we're good.
Okay.
That's
ready?
was fully
Okay.
charged.
Hold this balloon in both of your hands and slowly bring it close to the balloon that is hanging from the thread. What happens? It goes away because it has the same forces, so it
Yeah.
repels.
charge.
Alright.
Woohoo.
Look
Look at
There we
that.
go.
Look at
Can you
it.
see that? Can it just show up in video land?
Yep.
Play with the situation a bit. Try to see what kind of motion you can induce in by hanging balloons.
Wow, look at that.
I appreciate the sound effects.
Action movie right here.
That's like when
All
my mom's
action.
chasing me.
I haven't
You do something and I run away.
Okay, we
Okay.
get the idea. Go ahead.
Vigorously rub the balloon that is in your hands in your hair.
There we go.
Spend significantly more time doing this as compared to what you did in step 4. We're gonna be here all day.
We can watch the Mars and the Mercury's transit again.
Wait, so we just showed up.
Alright, where are we?
Once again, bring the balloon in your hands close to the balloon that is hanging on the thread. Note what happens and note how the motion of the hanging balloon compares to its motion in step 5
Alright,
and
let's see if
6.
there's any difference.
That's really intense.
Alright, go ahead.
Oh,
Oh, it looks about the same.
well, it's probably the same.
Yeah.
Oh, look. Oh no, he's spinning it circularly.
It's mixing it
Ooh,
all
fancy.
Okay.
Alright,
Guys,
we get the
Put
idea.
away the balloon that is in your hand. Put it away. Take a piece of tape that is at least 15 centimeters long and tape it to the
Dang.
top of the table.
Wait,
15 centimeters is a long piece of tape.
A tape
Look
punch.
at that balloon.
okay.
Tape hunt.
Do you want me to go find tape?
I think we need to find Zach a
But
comb.
you can't go in Miss Sean's office.
Okay.
So try a teacher's room and then.
Look at all this
Miss
action.
Cockerham doesn't have a
All
class.
the action.
Okay.
Oh yeah, that's a good one too. So why don't we read what we're gonna do with it?
Okay. Take a piece of tape, tape it to the top of a table.
Yeah, how long is 15? About-
15 centimeters, so. It says at least 15, so it doesn't have to be exactly, but it just has to be longer than that.
Alright.
Leave
Put it
a
on the
little
tape.
part of it unfastened so that you can remove it in a moment. Be sure to ask your parents which table you should use it for this,
You can use this
as
one
what you will
here.
do in the next step can damage the finish on some
Oh
tables.
gosh.
Quickly rip the tape off the table and grasp it at both
Your
ends.
head is.
Hold,
Your head would be positively
hold the tape
charged.
near the balloon with the
Yeah, it's pulling it
sticky
towards
Oh,
side
it is?
facing the
It's
balloon. What
working.
happens?
Look at that. It's because he knocked off the electrons off his head, so it's attracting it. That's cool. They should have had that in
Yeah,
the
balloons
book.
attracted to you.
All right, what else? All right, you pull it off,
So you pull it off
and then you take it to the balloon.
yeah, tape side facing the balloon.
All right.
Wait, hold on, it says. Quickly rip the tape off the table and grasp it at both ends. Hold the tape near the balloon with the
So
sticky
what's supposed
side
to happen
facing
with
balloon.
the tape?
It says what happens this time. It doesn't tell you
All
that.
right, read on in the white. It
Once
will
again,
tell us.
play with the situation a bit to see what kind of motion you can induce in the hanging balloon. Clean up your mess.
Please, that's a mess. Okay. All right. So what's explained about the tape? Can you read about?
When you rip the tape off the table, you were actually causing the tape to lose negative charges.
Oh, okay, now I get it. So
This
it's
is
positive.
this is because the
So
tape
we
leaves
gotta-
electrons behind and the
we should
sticky
get
residue
to it.
left on the table. Since the tape lost negative charges, it becomes positively charged. When you held that up to the balloon was attracted to it. Because negatively charged matter attracts positively charged matter. Opposites attract
I
people.
think I'm gonna get it from Stone because this is Cockerham's is out.
Okay, I'm gonna take Dearth.
Here we go. Here we go.
I think that's a little bit longer. Yeah, that's probably good.
12, I mean 15, was it?
That's probably good.
Alright, this
You
is-
gotta like put it down really good.
Alright.
I really
The
enjoy
idea,
your sound
Emily-
effects today.
The idea, Emily, when we rip it off, we have to rip it off, and
Remove the
we
electrons.
should be leaving electrons on the tape this time. So we should have a
For tape?
positively
This
charged.
is really.
So we don't have to charge this again or anything?
No, I think it should still stay
Okay.
charged. I
Alright,
mean, Zach can do it if he
Zach,
wants
go
to.
ahead and rip the tape off and approach the balloon with the sticky side.
She's
You can eat
probably
oil.
faster than that.
Oh, it did come toward it.
How do you know it's not Zach though? From all the balloon rubbing, like.
Well, but that would. Oh,
Is
yeah,
it coming toward it?
Yeah,
That's
well, actually,
cool. That's cool.
Let's see if it'll touch. It won't touch it though, will it?
depends on which side where my hair was.
Oh. Let's try it again. Why don't you charge the balloon a little with your hair? And
We get all on the bottom.
Just when you had fixed it.
this poor table. It's
Round and
gonna,
round and round.
gonna have
Finish
all
is gonna
these
go.
electrons on it.
Please video.
Alright,
Stop
that's
doing
good. That's good. Alright, now rip it.
Fast.
No.
Oh no. Technical difficulties here.
So fast. There you go. That's a good one.
Oh
Yep.
yeah.
You're like a magician.
I can't believe it worked
Crazy
today
hair.
with all the humidity. They said it might not.
Oh,
if
got
it
a little
was
shot.
humidity. Alright. Alright.
Magic.
From this demonstration, we can see that
It's cool, like.
charges attract.
Oh, it's so weird. The sticky and all the tape wasn't actually really sticky.
Oh, so it's
Unlike charges, repel. Oops, I got that wrong. Like charges, repel. And how do you spell repel? One L or two?
One.
like one.
I
Unlike
don't know.
charges, attract. Yeah, that looks a little better. Alright, we learned that probably in 5th grade, 3rd grade, something like that.
Opposites
And
attract.
it's still working from all those years ago. Alright,
Yay, 5th
so
grade.
those are the basic definitions or principles. Let's go on from there. What is it called? It's a material, and the material is one that charges move through easily. What's that kind of material?
A conductor?
Yes, charges move through easily, and that is a conductor. Guess what's next? Charges.
Inductor.
What?
Inductor?
A what? Inductor?
I don't think
No.
Insulator.
is that a thing?
Insulator.
Yeah.
Charges
I got the in
do
part.
not move easily. And that is through an insulator. And there's one more. And that's where charges will move under certain conditions. Anyone? Charges move under certain
No, it is.
Either.
conditions.
Can we play Hangman to figure it out?
Yes.
Do we know what that is?
Wait.
It's not an insulator, it's not a conductor.
Is it like a mix
It's
of the
a
two?
consolator.
Consolator.
It's in a computer. You know how computers sometimes when it's flowing through the chip, it's on, and when it's not, it's off. It's binary, 1, 2, everything's
Digit?
binary.
Electricity.
So semi, does that help?
Wait.
Semiconductor.
Right,
Oh,
semiconductor.
I knew that word. I know some of those
I
words.
know some of these words.
The
Yeah.
basis of a computer's operation is
Mm,
this.
Good job, computer.
Charges move under certain conditions, and they don't that's inferring they also do not move under other conditions. The law of conservation of charge. And that is the total amount. Law of conservation of charge, total amount of all charge in the universe. How shall we finish this? It's always the same. We've seen conservation of momentum, we've seen conservation of, hello. We've increasing conservation of momentum and conservation of something else, I can't think of it right now, but the total amount of all charge in the universe, and you finished it, MK? I want to finish